Finding the intercepts of a quadratic. So x-intercepts, recall x-intercepts are where y equals 0. Y-intercepts are where x equals 0. And there are three other names for x-intercepts: zeros, solutions, or roots. So we find x and y-intercepts in the same way as we did for linear equations. For a graph, we look on the x-axis or the y-axis. For a table, we find where y equals 0 or x equals 0. And for an equation, we substitute in y equals 0 or x equals 0. So the y-intercept. The y-intercept, it's right there. It's 0, 8. The roots, they're right there. They're negative 4, 0 and 2, 0. The y-intercept and x-intercepts of this graph. So the y-intercept, don't know what that point is exactly, but it's about negative 6.7, oops, wrote that backwards. 0, negative 6.7. Remember, it's a y coordinate, so that has to go second. And then here are our roots. Our x-intercepts are there and there. That's negative 4, 0 and 5, 0. The y-intercept is where x equals 0. So here's where x equals 0. It's 0, negative 9. The roots are when y equals 0. So that happens twice. It's negative 3, 0 and 3, 0. The y-intercept and solutions for this equation. So for y-intercept, if you remember, you know it's just 15. But if you've forgotten, you know it's where x equals 0. So we're going to say y equals 0 squared plus 8 times 0 plus 15. 0 plus 0 plus 15 is 15. So we have 0, 15. That's the y-intercept. The solutions are when y equals 0. So 0 equals x squared plus 8x plus 15. 0 equals x plus 3 times x plus 5, unless you want to do quadratic formula, but that's going to be a lot more work. So x equals negative 3 or negative 5. So negative 3, 0 and negative 5, 0 are our two solutions. Please don't write negative 3, negative 5, because that implies that it's one point that's definitely not a solution because it doesn't have y equal to 0. All right, y-intercept and roots for this function. So the y-intercept, I'm going to do it the fast way this time. The y-intercept is 0, 98. We see that based off of C. For the roots, we'll say 0 equals 2x squared minus 28x plus 98. Let's divide all this by 2 to make our lives easier. Minus 14x plus 49. The numbers that multiply to 49 are 7 and 7. And if they're both negative, that'll work. So 0 equals x minus 7, x minus 7. So we get x equals 7, or 7. So that's really just one root. 7 equals 0, 7, 0. So we have one root, which also means that it's the vertex. The y-intercept here is going to be 0, 11 from there. The roots, set 0 equal to 6x squared minus 2x plus 11. Let's do 6 times 11, getting 66. 1 and 66, 2 and 33, 3 and 11. Sorry, 3 and 22. 6 and 11. And I think that's it. Which means that this can't be solved with factoring. What we need to do is pick A as 6, B as negative 2, C as 11, and bust out our quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So here, negative b plus or minus the square root of b squared minus 4ac all over 2a. So we have positive 2 plus or minus square root of 4 minus, that's disgusting, that's big, negative 264 over 12. This is definitely going to be negative, so no solution. There are no roots for this function. We have the y-intercept is less obvious, so for the y-intercept we need to set x equal to 0. It's not just the negative 12, because it's not in standard form anymore. 0 minus 8 squared minus 12. 3 times negative 8 squared minus 12. 3 times 64 minus 12. 3 times 64 is 192 minus 12 is 180. So 0, 180 is the y-intercept. For the x-intercepts, we'll set 0 equal to 3 times x minus 8 squared minus 12. Add 12 to both sides. So 12 equals 3 times x minus 8 squared. Divide by 3, x minus 8 squared. Square root both sides, so get plus or minus 2. Split that into two equations. We have 2 equals x minus 8, or negative 2 equals x minus 8. So we can add 8 to both sides of both equations to get 10 equals x, or 6 equals x. So that means 10, 0 and 6, 0 are our two solutions. Last one, the y-intercept for this. Here, the y-intercept is when x equals 0. So we have to say h of 0 equals negative 20 times 0 minus 1 times 0 plus 5. H of 0 equals negative 20 times negative 1 times 5, which is 100. So 0, 100 is the y-intercept. The roots, they give them to you. They're right there. 1 is the first root, and the other root is negative 5. Remember that we use the opposite sign, so those are our roots. That's it. That's how we find intercepts of a quadratic.